Welcome and thank you for joining us on DisrupTV. My name is Vala Afshar. I am the Chief Digital Evangelist at Salesforce and your co-host for the next hour. We welcome you to follow us on Twitter at DisrupTV Show. Send Ray, myself, and our distinguished guests your questions live using hashtag DisrupTV. It's my pleasure to introduce my co-host. He's the CEO and founder of Constellation Research, best-selling author of Disrupting Digital Business, regular contributor to Harvard Business News, Harvard Business Review, ZDNet, and many other publications. I often now see him on CNBC and Fox News. And in my humble opinion, one of the top futurists to follow on Twitter at RWANG0. Welcome, Ray Wang, to episode 151 of DisrupTV.
Hey, thanks a lot. I'm here with my awesome co-host, Vala Afshar. He's the Chief Digital Evangelist at Salesforce, but more importantly, a thought leader in his own right, one of the top followers on Twitter for CMOs, CIOs, and transformational change agents. So, but who do we have? Talking about transformational change agents, who do we have today on this Friday?
We start our show. It's our privilege and honor to have Dr. Steve Scott, CTO at Cray. Dr. Scott serves as Senior Vice President and CTO at Cray, responsible for guiding the long-term technical direction of the company's supercomputing, storage, and analytics products. Cray is a global leader in supercomputing. For over 40 years, Cray has been developing highly advanced computing solutions for the world's most complex science, engineering, and analytics challenges. Cray introduced the world's first supercomputer in 1976, even older than Ray. Dr. Scott rejoined Cray in 2014 after serving as principal engineer in the platform group at Google, and before that, senior vice president CTO for NVIDIA's Tesla business unit. You can learn more about Cray by following their Twitter handle, CRAY_INC. Welcome, Dr. Scott, to DisrupTV.
Hey, Vala. Hey, Ray. Great to be here.
Wow, this is exciting, man. 27 patents, a Seymour Cray Award. I mean, that's a hard award to earn anywhere in the world. This is awesome and really, really excited. I do want to talk about what's happening in the world of exascale computing on the US, the business and economy. This is one of the top national security priorities, as well as in terms of thinking about what happens in the future of the economy. Give people an idea, what is exascale and why is it so important?
Yeah, well, exascale just refers to being able to do an exa operation. We all know about kila and mega and giga. Well, exa is a billion. That's a 1 followed by 18 zeros. So it's a huge number of calculations. Each one is like a big multiplier or addition or something of a 15-digit number. And so an exascale computer can do that many calculations every second. So that's just a point in a continuum. There's nothing magical about exascale. If you think about it, we traditionally we've done about another factor of 1,000 every decade or so. So we used to talk about terascale and then petascale, and exascale is what we're going after now. But we're thinking a little bit beyond just the number. The exascale era is kind of it's kind of changing the way that people are using computers now. HPC is starting to be deployed more widely beyond just government and research labs and into business. We're having more algorithmically driven business. We're seeing more of the convergence between AI and analytics and simulation. And so all these things are kind of wrapped up in what we call the exascale era. But if we think about why high-performance computing in general is important for the US, it's really sort of threefold. It's really important for national security. Think, nuclear stockpile stewardship and supporting the Department of Defense and code breaking and such. It's also really important for pushing scientific computing forward. Computing is now the universal scientific instrument. So it's used in every field from physics to chemistry to biology to geology and astrophysics, et cetera. And then lastly, it's really all about industrial competitiveness. Companies use computers to design better and stronger and lighter materials, to make more efficient engines, to make safer, quieter cars. They used it to optimize transportation logistics and supply chain. all, you know, in the world of finance, in the world of healthcare, every area of industry is also dependent on these computers. So it's becoming really, really important across the spectrum.
That is amazing. I spoke to Kevin Kelly, the founder of Wired Magazine, a couple of weeks ago, and he talked about the internet's operating system. And he said that, you know, it first started as first generation operating system. The internet was reading documents.
Right.
And then the second generation of the internet operating system was reading people. The growth of social networking, and now the #1 use of web is social. And with Internet of Things and digital twins and the immersed augmented virtual reality expansion, he believes the third operating system of the internet will be machines being able to read everything. And so if you recall this week at the Recode conference, Mary Meeker's Internet Trends had a slide where IDC projections showed from 0.5 zettabytes of data 15 years ago to 128 zettabytes of data being produced by 2020. Can you talk to us about what industries are leading in terms of adoption of supercomputing in order to just deal with this incredible avalanche of data that hopefully companies can leverage to glean insights and opportunities to engage with their stakeholders, employees, customers, business partners, and communities that they serve?
Yeah, well, the statistics are something like every 2 years we produce as much data as has been produced in the history of humanity before that time. So it's just amazing, this deluge. The companies that are at the forefront, really at the forefront, were the big web, cloud service providers. So you think about Google and Microsoft and Amazon, right? Because they've got all this data, and so they were kind of at the forefront of the whole new movement of AI, deep neural nets. Because they had so much data and so many things that they could do with that. So if you think about any industry that has a lot of data, they're going to be at the forefront in their field of trying to extract insight from that. So for example, think about self-driving cars. Sure. You've got Tesla that has thousands and thousands of cars out there. They're all sending all this telemetry back, and that's a tremendous amount of data that you can extract insight. You think about just any kind of giant commerce company like Walmart, right? They've got an incredible amount of transactional sales data that they can leverage. Think about companies like General Electric, this idea of the digital twin. They're kind of at the forefront of that, where every turbine or jet engine or other machine, CAT scanner that's out in the field, they can now actually have what they call a digital twin back home, which is a representation not only of that model of computer, of machine, but that specific machine. So that representation will have the information about, what metallurgy batch was used to create the thing, what's its service record, all the things specific to that particular instance. And so now you have the ability to do things like predictive analytics and failure analysis, right? You can take a look at all the data related to this specific instance of a machine and say, we think that you need to service this now. And so any industry that has a large amount of data is really looking at starting to exploit that data. We mentioned that a very small fraction, every couple of years we produce as much data as has ever been produced before, but a very small fraction of that data has been analyzed. So it's really a tremendous untapped opportunity.
Wow, that's crazy. So we're cranking out all this data. Nobody's even looking at it. We're not even getting to the patterns of this, which means we can even barely get to any level of machine learning or AI.
Yeah. There's we are right at the very front end of this. Again, the companies like Google and Microsoft, and then their counterparts like Baidu and Tencent in China, they're quite a bit farther along, but everybody is interested. I mean, I would say universally, even all the people that we've traditionally sold supercomputers to that do simulation and modeling, every one of them is interested in AI at this point. They're just kind of doing tire kicking at this point, but they're all headed in that direction.
So this convergence of supercomputing, AI, and analytics is happening right now. What does that mean? Do I do that? Because we see a lot of supercomputers, they're not in the cloud. They're typically on-prem, private data centers that are happening. Will we start seeing supercomputers in the cloud?
Well, Cray's actually got an arrangement, a partnership with Microsoft to actually allow people to access Cray computers in the Microsoft Azure cloud. For the most part, we don't think of cloud versus on-prem computers. We really think of cloud plus on-prem computers. They're both very good at doing certain things that don't necessarily overlap. And so for example, cloud computing is wonderful if you've got bursty workloads where you want to do a lot of computing today and not so much tomorrow. You don't have to buy a machine and try to keep it well utilized. You can kind of elastically grow your compute as necessary. It's also really nice because you can easily spin up a new compute capability when you need it quickly. And there's a tremendous amount of software that's out there that you can leverage. All these services that are available in AWS and Azure, et cetera. On the other hand, if you can keep your machine well utilized, even north of 50%, much less than 90+% that most of our customers keep their machines utilized, it's a lot cheaper to buy your own machine, even when you consider the cost of electricity and a building and administrative staff and all that. And so if you can if you've got a workload where you're constantly needing it, it makes more sense. And then the types of computers are rather different. If you think about the big cloud data center, it's large, heavily shared, virtualized Ethernet clusters. Whereas supercomputers are really built with a custom designed interconnect and software stack, very tightly controlled locality, and really designed to take all the processors and bring them to bear on a single problem. So they're very complementary, and we think it actually makes sense to move to a world of what we call hybrid cloud, where you have a combination of on-prem or even a supercomputer in the cloud, and then augment that with general cloud services.
So shifting workloads, shifting compute patterns, right? At that point, you take a hybrid approach.
Right. You run the right stuff in the right place, basically.
Right stuff in the right place. So Steve, if my 16-year-old daughter, who's about to be a junior in high school, asks me, Dad, what's quantum computing? Can you help me answer that for her? And also, what does quantum computing, what is its impact on supercomputing and the future work at Cray?
Yeah, we could spend a long time on this. What is quantum computing? Wow, it takes advantage of the fact that it's over in the quantum realm. You can effectively have a bit, which is normally we think of as 0 and 1. Yeah, in the classical computing world, it's either a 0 or a 1. In the quantum computing world, it can effectively be both with some probability distribution. And so what you can do is you can simultaneously explore all 2 to the n states. So if you have n bits, call it 100 bits, 2 to the n, 2 raised to the 100th power, is an incredibly large number. And you can kind of simultaneously explore all of those states at the same time, looking to optimize some function. Okay, so what it allows you to do is for certain kinds of problems, you can do things that would take intractably long on a classical computer. So that sounds really cool. The problem is that, well, it's multifold. There are a lot of practical problems with building a quantum computer. The bits, they're called qubits, they tend not to, they're not very stable, they tend to decohere, they tend to have a lot of errors, and so there's a lot of practical problems you have to deal with. Let's just say we can get past all of that. The other problem is that there are only a few core quantum algorithms. There really aren't that many. You can't do quantum computing across a broad spectrum of different applications. You have to have a problem that has exponentially large compute, but you can specify the problem in just the n bits you have, not 2 to the n, but just n bits. And the output also has to fit in those n bits. So there's a narrow range of problems, like, for example, factoring large numbers that are used, product of 2' numbers that are used in cryptography. It's the basis for most modern day cryptography. And it's very hard to factor large numbers. That's a problem that you can specify very easily, concisely, has exponential compute, and then the output is also very small. So there are a handful of things like that. Quantum chemistry, simulating actual quantum chemistry and materials, is another one where quantum computing fits really well. But most problems that we use supercomputers for will never be able to be addressed by a quantum computer. So, crashing a car, predicting the weather, nuclear fusion, all of these sorts of things, quantum computing is not going to address. So it's a really interesting technology. It'll probably be 10+ years before you have any practical benefit because it's very complex. But even when it happens, It will transform a few narrow ranges, like the fields of quantum chemistry and cryptography, and it won't have a whole lot of impact on the rest of the industry.
Wow. Speaking about
But
that.
it's fun to talk about.
Yeah, it is
I'll
actually.
make sure my daughter watches this segment, so thank you.
Hey, we're going from qubits to Shasta. Talk about Shasta. You guys redesigned recently how you're going to handle new workloads, supercomputing. You guys went from the ground up. Why Shasta? What changed in terms of the design? Because you guys have been using the same, not the same, but pretty much been improving the same original concepts for quite some time.
So Shasta is Cray's next generation of system. We've been working on it for about 5 years, and it will debut later this year. And it is a pretty transformational change for Cray. What we've tried to do in both the hardware and software side is to take all of the scale and performance that we've had traditionally, but marry it with a lot more flexibility to kind of live more comfortably in the new cloud-enabled world where people expect the ability to dynamically provision environments. So the software environment is much more flexible. You can mix and match components that come from Cray or third-party commodity software, whereas our previous software stack has been very scalable, but very monolithic and hard to change. So opening up to the cloud world is a big part of it. The other part of it is dealing with the fact that the hardware world is becoming much more challenging. Many of your viewers are probably well aware of the fact that Moore's law is kind of plateauing and performance isn't improving the way it was. People are turning to architectural specialization to try to get performance in the future because the underlying silicon isn't giving it to them. And so there's a lot more diversity of processors coming, and they're getting hotter. We're now talking about, traditionally processors have been maybe 100 watts or 200 watts. We're now driving up to the 500 watts. We've even have some future processors that are 1,000 watts. You know, if you just think about taking an old incandescent 100-watt light bulb, running it for a while and then touching it, you know how much heat that generates. Now imagine 5 or 10 times that much heat, and then trying to put 500 of these into a single cabinet and run them all, right? And so it has there are a lot of power and cooling kind of challenges that come with that. And so the hardware Shasta is designed to be much more flexible, deal with these hotter processors. And we're also building a new interconnect called Slingshot. And Slingshot is all about taking the enterprise world of Ethernet and marrying it with the HPC world of high performance networks, bringing those together again to try to better serve this new exascale era with this converged big data sorts of workloads.
Can I ask you a real quick question about that on the networking side? Because we feel like, old is new again, right? Cloud is mainframe time sharing, right? This thing is a BT100, right? And, if we think about computing, when you think about NoSQL is really like key value store, right?
Right.
So what are we missing? Aren't we missing token ring? Shouldn't token ring come back? Slingshot token ring? I was kidding.
No token ring.
Token ring's not coming. No more banyan vines. I mean.
No, exactly. No. We do have an interconnect that we designed a while ago, a topology called a dragonfly, which is kind of cool. I won't get into that. But it's really all about trying to sort of table stakes is taking advantage of the next generation signaling. So you build a really big switch that has lots of ports running at 100, 200 gigabits per second per port. So, but then the most impressive thing that Slingshot does, that interconnect, is really move the ball forward in terms of congestion control. So the problem that we have on today's systems is that people will run a job today and then they'll run it tomorrow and get different performance because somebody else is doing something on the network.
Yep.
The really interesting thing about Slingshot is it completely eliminates that interference between applications. It's very good at doing congestion control and slowing down the guys that are causing congestion so they don't interfere with the others. And that's really the most sort of the crown jewel there. And it becomes increasingly important in this new heterogeneous world where you've got big data, AI workloads and analytic workloads and simulation workloads and a lot of data motion. You really want to keep all of those different parts running without interfering with each other.
Wow, and from 5 hops to 3, that's pretty wild. So
yeah, that's all about, we can actually go up to 250,000 endpoints and only have to take 3 hops of the network. So that's that dragonfly topology at play, along with having a switch with a lot of ports.
My final question, Steve, just maybe a quick overview in terms of convergence of supercomputing and cybersecurity. You mentioned security when we were talking about potential use cases for quantum computing encryption. Can you talk a little bit about convergence of supercomputing and cybersecurity?
Yeah, well, I mean, cybersecurity basically is a supercomputing problem. It's this constant struggle, this war, if you will, between the white hats and the black hats.
Yeah.
And computing is really both the offensive and the defensive weaponry in that war. And so there are a couple of ways in which supercomputing comes into play in cybersecurity. One is in traditional cryptanalytics. So, one of the largest customers of Cray has always been the intelligence community, the people that are, doing offensive and mostly defensive work to keep both our industry and our nation secure.
Yeah.
And that's very demanding of the memory and the network. And so it's a classic supercomputing problem. The other part of it is around data analytics. What you're often trying to do with cybersecurity is just watch everything that's happening and sort of automatically figure out what's normal and what's anomalous, right? And AI has a big role to play there. Graph analytics also has a big role to play there. And graph analytics is another one of these things that tends to be super demanding on the interconnect, because you're trying to transfer around lots of little bits of information and share them across nodes of a machine. And so that's something that traditionally does really well on a single node and is very difficult to scale. And so having really strong interconnects and the right kind of software can allow you to do both the cryptanalytics and the cybersecurity kind of watchdog elements.
That is wonderful, man. We are here with Steve Scott, CTO at Cray. And you can actually catch him next week if you're at the High Performance Computing event in Frankfurt, Germany. What are you speaking on, actually?
Let's see, I'm giving a talk. I'm giving a keynote at the Exicom workshop, which is all about actually the Slingshot network that I talked about. And then I'll also be doing Cray's vendor hot seat talk, where they put a bunch of vendors up on stage and they give it a few minutes to do their pitch, and then they get surprise questions from the panelists. So that'll be fun. But then mostly I'll be sitting in a hotel room talking to customers.
That is awesome. Hey, thanks a lot for being on the show. Thanks a lot for sharing insights on what's happening in the world of supercomputing. So happy Friday. Thank you.
Fantastic. Thanks for having me, guys.
Absolutely.
Awesome. Wow. From supercomputing to super people, who do we have next? What's going on here?
Yeah, I know. I'm talk about my head spinning with all the 18 zeros and bytes and exabytes.
What's after exa? Is it like yada or zeta, or I can't remember. All these like weird names, like from peta to exa to yeta. I don't know. I think it's yeta or something like that.
Yeah. So. We're fortunate. Our next guest is Melanie Nuce, Senior Vice President, Corporate Development at GS1 US. As Senior Vice President, Corporate Development, Melanie leads a team that investigates new technologies, partnerships, and business opportunities to increase relevance and reach of GS1 standards. GS1 standards are the shared languages businesses use to sell, grow, remain competitive, and even reinvent themselves. They allow you to easily identify, manage, and share product data with your trading partners, supply chains, customers to streamline operations, cut costs, and deliver richer, more satisfying experiences. Drawing on Melanie's extensive background in retail technology, she oversees the exploration of collaboration opportunities to help businesses leverage emerging technologies like Internet of Things, blockchain, machine learning. We can't wait to learn about all of that. Melanie is active in ongoing development of global standards and is a frequent speaker at education seminars and industry trade shows. She has the best Twitter handle. You can follow Melanie on Twitter at AuntMel, AuntMel. Welcome, Melanie, to DisrupTV.
Thank you so much, Vala and Ray. So happy to be here.
Hey, thanks. You were wonderful at our conference 2 years ago, talking about blockchain. Yes, real, it actually works. And we were talking about that point about standards and that importance for standards. And I think if you can give our listeners and our audience and viewers a feel of what GS1 does and why standards are so important. Why do people have to care about standards for data and collaboration, especially given how fast we're moving today in terms of innovation and transformation?
It's interesting. So going from quantum and supercomputing to a 1D barcode is probably a big letdown for the show. But, what I love about standards is it's a way to bring scale. So that's constantly what I'm talking about is, right, it's less about like the process of standards, as you know, it's not sexy, consensus, and we all have to agree on something, then everybody has to do it. But what we find with a lot of the big companies is they hit these adoption plateaus for their supply chain initiatives, and standards are a way to bring the long tail along. And so you've got that definition of standards, it's led by the big multinationals, and then you have adoption of standards, which is really about a whole industry. So our challenge, honestly, has been, we're a 45-year-old organization, and so we've been around a long time, and most of the time people will develop some sort of thing they think is competitive advantage, like back in the day when exchanging 8 attributes over a Kix 3270 emulator was like, high tech. And then they'll come back and say, well, I really get these electronic purchase orders across my entire supplier network. And so they'll say, we need to standardize this, right? So people can do it in a scalable way. And so GS1 is a community, right? We bring everybody together under kind of that guise of antitrust and non-compete. Let's focus on what's collaborative. And then we work with technology partners who really bring the standards to life. So I always like to say standards are only as good as the tech that will enable them, because companies can't adopt without the tech. But the challenge is that tech is moving so fast that if we don't get the standards to keep up with that, the industry will have moved on to something else before we ever get clean adoption of the thing we were trying to do. So we've really tried to elevate our role in terms of, partnering with tech and moving at the speed of tech in order to deliver what businesses need, instead of kind of waiting for industry to think, oh, I have this problem, maybe standards could help.
So it's like agile standards development that's going on here, right? I mean, no more waterfall waiting for this thing to happen. So.
That's right. We've become Scrum and Safe and Agile and XP like everybody else.
That's awesome. Ray and I had the privilege last year of, first we interviewed Vincent Cerf, who, defined the TCP IP standard, which some argue scaled the adoption of the internet. We both had an opportunity to speak with Sir Tim Berners-Lee and the TCP standard and the web and scaling of the web. So the profound impact of the internet and the web in this new digital economy, where the most valuable companies in the world are internet companies. We all appreciate how standards can really be the rocket engine for scale and adoption of emerging tech. And now today we're talking about distributed ledger with blockchain. We're talking about all of the various branches under this umbrella we call AI, with NLP, machine learning, deep learning, computer visioning, smart robotics, and all of that. You have the Internet of Things. Of all these emerging technologies, ones that have seen hyper growth in the last 5-10 years, like IoT, AI, and blockchain, which one is the hardest for you to galvanize a group around to build a standard, knowing that these are potentially highly disruptive technologies that will redefine the next Amazons and Googles and Apples of the world?
Well, they're all hard. Gosh,
they're all hard.
Our team jokes that we lay on the floor at night with cold washcloth over our head because we're just like exhausted by trying to solve these problems. I think you guys talked about it a little bit before with Steve around convergence. And so that's really one of the things my team has seen is digital convergence. Ray, you talked about data and how we've largely not tapped into this data. So in terms of machine learning and AI, one of the things we've been discussing is how it's really difficult to train algorithms to do stuff when the first thing you can do is take a bunch of unstructured data and put structure to it. And so there are kind of two streams of thought. One is if you have structured data, which for the most part, supply chain data and product master data is structured, right? So let's take that semantic language and apply that to machine learning so that we can start to get more business value out of that data, especially when you start pairing that with, listen, it's not that exciting to talk about a tube of toothpaste, but when you start looking at that toothpaste performance at retail and what are consumers saying about it, how do you tie user-generated content together with transactional content, and then start building these real insights that I can actually make business decisions on? So it's interesting because supply chain people generally feel like our job is to take cost out of the business, right? Make it cheaper, faster, better. And what we're trying to say is you guys are sitting on a goldmine of stuff that could actually help your product development teams and help your consumer insights and your marketing, and the money isn't really sitting with them. So I think for us, really synthesizing the data and converging the tech, because I think that, you know, sensor data and what IoT is going to bring, whether it's connecting products or connecting them through the devices that are in the home or in the industrial setting, creating that data that actually needs to tie to the actual product execution and physical movement of product is so critical. So we often talk about convergence, particularly of data, but also ledgers, not so much, you know, like, listen, blockchain, blockchain, blockchain. Okay, I got it out of my system. Like, we all have to talk about this, but the notion that distribution of data is reality. And I can't just go to some big cloud in the sky, right? Proprietary data silos are never going to help you get ahead. So how do you leverage what's growing, things like DLT, and use that to your benefit to actually start to extend through your value chain? So you're not taking all the burden on yourself, but you're working with partners so that everybody kind of achieves positive outcomes.
I think you've exceeded your quota for the use of the word blockchain today. I'm so sorry. That's kidding.
Oh.
No, I mean, you know, this is a big point, right? And, you know, given some of the other areas that we've been talking about, like how commerce is massively built on data, but it's not just the data, it's the metadata, right? Yeah. I mean, all that contextual data around location, how did you feel? What was your blood pressure, right? That's all gonna be important. The weather, right? Geospatial, that stuff. I mean, there are no standards set for that right now. Right, and that's the big difference between being able to serve up a next best action to say, hey, let me make you a recommendation that seems natural to something that seems really creepy, right? And getting that right is really important. So and so we start seeing this. Now, you wrote this article, Trust in Technology. Talk a little bit more about this in terms of how that commerce is becoming more data reliant and why we need standards to enhance that trust, especially given, you know, some really regulatory areas as well.
Yeah, well, I think one thing is when you start to see multi-party reliance on a system of data, you start to build trust. So, you know, we always like to say that the goal is to be able to achieve trust in a trustless world. And what we've learned through all of this exploration around decentralization, in large part, people still need some sort of trusted party. And I'm not suggesting an intermediary by any means, but a trusted party that has kind of set rules. Some of the interesting work that W3C is doing around verifiable credentials, right? So taking an identity, and you think about GS1, what do we identify? We identify products. We identify everything that crosses a point of sale, giving a digital validity to that identity by making it, right, its identity cryptographically secure and signed by whoever has an attestation. I'm P&G, I'm telling you about this specific product. GS1 is endorsing, yes, this is a legitimately licensed product. You wouldn't believe how much barcode hijacking goes on the internet. But so, you know, building this notion that there are people who have credible ways of attesting to the validity of data and then tying those kind of credentials together in a string to kind of increase the downstream party's reliance on that data as trustworthy. So we actually, I mean, we're very focused, I think, one, on structure and giving semantic structure to things so that you can do them in a repeatable, scalable way, but also that common language that again, it's the foundation, right? Nobody's saying that GS1 is solving prescriptive analytics problem, but we're actually building frameworks so that the data that people use can provide, to your point of not just predicting what will happen, but giving me the answer for how to either avoid a negative or enhance a positive, right? Helping people scale that kind of investment in data is really what we think is important.
And you guys do something like, what, 6 billion barcode scans a day?
Yes. Yes, and people don't even know that, right? Well, the best part that has happened to, in my opinion, the best thing that's happened to GS1 in a while is self-checkout. So when you get on a plane and somebody says to you, so what do you do? And, you know, GS1, is that GSI? No, GS1, global standard. What do you mean by global standards? I'm like, do you do self-checkout? Oh, yeah, I do that. I said, well, the little bars and stripes that go across the scanner that tell you what price the thing is that you just bought, that's GS1. Oh, that's a standard? Well, sure, because you have to make sure that a bag of potato chips doesn't have the same number as a bottle of soda. So I think in that regard, it's actually been really great to say this humble barcode, which, right, I think you guys know this month will experience its 45th year since the very first scan of Wrigley's gum in a Marsh's supermarket in Ohio. Hey, this is the technology that outlasted the floppy disk, people. So
William M. Wrigley on a double mint chew gum, 25 cents, UPC, let's go.
Okay, so you just gave us a historical perspective. of the first use of the code. Can you give us some proof of concepts or describe some interesting proof of concept or pilots that's happening, some breaking news or insights into future of GS1 and some of these interesting projects that you're actively participating in?
Definitely. I mentioned a little bit about digital identity. So we're really looking at how to use secure GS1 identities in a digital environment and make them valid and valuable. Another one that's really interesting is in the B word, which I won't say it again, but you know, what we're finding with supply chain, and I think if you guys remember, I got into a pretty heated debate with Richie on the stage because supply chain use of blockchain is so lame. And I said, listen, I can't even get these guys to put a license plate on their cases. So serializing cases is a big deal. Blockchain is like rocket science to them. But what we're finding 2 years later is that people actually understand the value of distributed data and smart contracts to kind of automate business agreements. And so we've started our first foray into sort of working with open source communities on developing legitimate frameworks for building blockchain applications that will answer supply chain business challenges. And so we're doing a bunch of contribution there. And then I would say the third thing, which is very near and dear to my team, is web enabling the barcode. So the UPC, it goes beep when you scan it, right? Whether it's at point of care or point of sale, it's phenomenally reliable and cross-reference to the right cloud data set, you know what it is. But by itself, it provides no innate value beyond that purpose. And so we've been, we actually last summer ratified a standard, we call it Digital Link. It's about taking the structure of a global trade item number, what goes into that UPC, and creating it in a URI. That means if I put a 2D barcode on a product and I take this device, just turn my camera on, I can, you know, I don't have to take the picture, just point it, it will resolve to a web address. And a series of links that would give me not only ingredient data and provenance and allergen information, but would give me recipes or care instructions. Or when I get in the home, one of my favorite use cases is throw the thing in your smart trash can and then it automatically generates the reorder with your grocer. So I think, right, the notion of autonomous,
so cool.
Yeah, and consumer engagement. So we've really been trying to push, we call it the triangle. You think about the value of the barcode to a retailer, right? Efficiency at point of sale, the value to a brand in terms of getting data back on what's performing, but now the value to a consumer, not only kind of the showrooming, I'm in the store, I want to know more about this, but once I get it home, can I register this? Can I transfer ownership of this? Can I replenish it? Can I use this with other products in my home? And it's really, you know, a 2D barcode, listen, I know it's not quantum computing, but what it is the first step towards sensor-based identity, that when you put that on a dumb product and then you connect that to a smart product, now working together, those two things. I think you guys, you remember, I think, is it Michelle Killebrew-Ray that does the smart sous vide machine? Right?
She's the CMO for that sous vide company, yes.
Yes, right, but so when you think, okay, if you can make a sous vide smart, why can't you make a box of rice smart? You know, so these are the questions we ask ourselves and try to come up with creative answers to that will actually help our members, and then I think extend that relationship with the consumer, because I'll tell you something, those big digital giants are starting to get their hands around all that data, and sometimes the brand is being left out of the conversation. So finding a way to keep them involved.
So a question that, you know, as you think about algorithmic economy with sensor-based ingestion of unbelievable amount of data that can potentially provide personalized offerings, like knowing how to, you know, replenish your fridge based on your dietary habits, do you think at some point there'll be a strong emphasis on standards that help govern ethical and humane use of technology, whereby we're ensuring there's a level of responsibility with all these technology providers so that there isn't a misuse of data and we're not crossing the privacy or ethical use fine line that exists today when we have this incredible insights about individuals, organizations, and brands?
Yes. Well, I'll tell you, we're actually focused on that. We did a bunch of work in passive UHF RFID, right, in the last 10 to 15 years. And one of the big things that we did was a huge public policy effort to help explain that the identity embedded in an RFID tag is just saying this is this product, right? It doesn't say that it's Vala's product or it's Ray's product, it's just a product. And so there's a whole notion of consent and opt-in that we've really, like, privacy impact assessment, understand it, right? Help you consumer in clear language, understand it. Partner with other organizations. Interestingly, IEEE has a huge effort right now going on around, right, ethical use of data and AI. So we can't do this all ourselves. The US team is a tiny little nonprofit of, 150 people dealing with all of these trillions of dollars in trade that go on with our members. So I think working on those elements of it, as well as the huge regulatory. So we're not any kind of lobbying organization, but we do a lot of advocacy with government agencies around how standards can bring value. And so by virtue of our role in the data space, then we get partnered up with a lot of other orgs that are looking at ethical use of the data. But, and I think in all fairness, that line has been crossed, right? And so now you've got everybody sort of looking at it with a microscope, and we really are huge fans of the potential for standards around anonymous segmentation, right? How do you avoid that correlation nightmare that happens? And I don't have all the answers, but it is something that our community, and we're very fortunate because we've got the retailers, the brands, healthcare community, as well as the tech providers and the really big tech guys helping to provide some insight into us to teach us the things we don't know about that.
Well, we're going to see a lot of convergence here. I can see that with the blockchain going on, with the barcode going on, with what's happening on the AI side, and definitely something that's big there. But hey, your former debate person on the panel, IEEE, Richie, he's actually in the Fair Trade Standards Committee for IEEE. So you're going to see that as well for fair trade data. So something big popping along the way. So maybe you teach.
Melanie, you were awesome. Thank you.
We're going to hear it with Melanie Nuce, Senior
it.
Vice President, Corporate Development at GS1 US. All the innovation, cool stuff. You can follow her Twitter at AUNTMEL. So thanks for being on the show. Happy Friday.
Thanks, guys.
You're terrific. Wow. Incredible insights again. And
we're back to back on people that are blowing our minds. This is amazing.
Yeah. Well, it's not going to get any easier for you and I in terms of getting pearls of wisdom dropped on us in the next 20 minutes. Our final guest, where we call the cleanup hitter, is a DisrupTV Hall of Fame first ballot inductee. Byron Reese is the CEO and publisher of the technology research company Gigaom, which I believe all of our audience is familiar with, and founder of several high-tech companies. Byron has spent better part of his life exploring the interplay of technology and human history. He has obtained or has pending patents in discipline as varied as crowdsourcing, content creation, and psychographics. The websites that Byron has launched, which cover the intersection of technology, business, science, history, together have received over 1 billion visitors. Byron is the author of acclaimed books Infinite Progress, How Technology and the Internet Will End Ignorance, Disease, Hunger, Poverty, and War. His new book, The Fourth Age, Smart Robots, Conscious Computers, and Future of Humanity, is described as entertaining and engaging by New York Times and was JP Morgan's 2018 Summer Reading List candidate. You can follow Byron on Twitter at BYRONREESE. Welcome back, Byron, to DisrupTV.
Thank you. So happy to be here.
Hey, thanks all for being back. I mean, you've been here 3 times, and we've been talking about all types of issues. What's hot on the reading list? The rumor is that this AI superpowers book is everywhere, and every government, people are freaking out, trying to figure out what's going on. So I don't know. When you look at stuff like this, what is hype? What is fear mongering? What is the truth? And how should people plan for this stuff?
Well, the way I see it, is first of all, you have to kind of, when people say AI, they mean actually 2 very different things. So, and you have to kind of figure out what it is they're talking about. So you've got people like Elon Musk who say they're afraid of AI, and you've got people like the late Stephen Hawking who say they're afraid of it, and they're afraid of a technology, a general intelligence, which we don't know how to build. That's an AI as smart as you and I. It's creative. It's like what you see in the movies. And that's a kind of AI that is highly theoretical that some people are afraid of. The other thing people mean when they say AI is what we know how to do today, which interestingly may have nothing to do with that other technology. It may not be that we're on some progressive slope to get to that general intelligence. We may not have even started working on it. But what we know how to do today is really a simple idea. And it says, take data about the past and study it and make projections into the future. And we call that narrow AI. And we use it to train a computer to do one very simple thing. And the fear around that is very different. It isn't that it's going to somehow take over, but as expressed in AI superpowers, the fear is that it's going to take away jobs. Kai-Fu Lee says 40% of work is going to vanish. You hear other sorts of things. Now, in my book, I try to give all viewpoints a very fair hearing, and I don't ever really say what I think. That being said, I don't think that is going to happen. I don't think there's any chance of that happening. And if I can make that case in 2 minutes, the interesting thing is if you look in the West across 250 years of economic history, we've never had unemployment never had it above 10%, other than the Depression, which was a special case. And in that time, you had really disruptive technologies. You had the assembly line, you had electricity, you had the replacement of all animal power with steam power, which happened like almost overnight. And if I showed you a timeline of 250 years of unemployment history and said, find those on there, you couldn't do it because they didn't cause any unemployment. You say, well, how can that be? Because they clearly destroyed a lot of jobs. And the answer to the riddle is that what happens as technology comes along, I've tried to figure out the half-life of a job, and I think it's 50 years. I think every 50 years we lose half of all the jobs. I think it's been going on for a long time. I think it's going on now. And what happens is technology creates new ones. There's an infinite number of jobs out there. And the problem is you can only ever see the jobs that are going to be destroyed. You can never see the ones that are going to be created. If I went back 25 years to when Mosaic was released, and you guys are forward-looking guys, and I said, hey, in 25 years, look at this thing. Billions of people are going to use it. What's that going to do to jobs? Well, y'all are smart guys. You would have said, look, there aren't going to be any more travel agents. There aren't going to be any more stockbrokers. They're not going to be yellow pages. There's not going to be, newspapers are going to have a hard time. People are going to do their shopping online. And you would have been right about everything. You would have seen every job that would destroy. But no matter how forward-looking you are, you wouldn't have said, oh, there'll be Uber and Airbnb and Etsy and eBay. Oh, and Google and Alibaba and Twitter, and all of these things. You would not have seen a million new jobs created.
Yes, sir.
So, I'll just close by saying this. I don't work harder than my great-grandparents worked, but I live a much nicer life than they ever dreamed of living. And why is that? It's because an hour of my labor produces more than an hour of their labor ever did, because I have technology. And in the end, these technologies multiply human ability. That's all they do, And that's good for people. And if you don't think it's good for people, you should advocate that everybody has to work with one arm tied behind their back, because you would lower everybody's productivity. And it would take twice as many people to do anything. And you'd create a bunch of new jobs because you need all these people. But the jobs would pay terribly badly because everybody's productivity is down. So imagine, a third world where you get an extra arm and your productivity goes way up. That's not bad for anybody. And so that's what I think. I think it's a lack of imagination. You can see what will be destroyed, but none of us, my children are going to be, chort wranglers and flim-flummers and all these other Dr. Seuss sounding things that haven't been invented. That
is you're absolutely
right. When your 16-year-old daughter asks you about quantum computer, does she also say, what should I study today to be relevant? And what would you tell her? What do you tell her?
I often tweet almost weekly that dear high school students, learn how to write well, learn how to publicly speak, learn how to negotiate, learn.
That's actually it.
Honest.
No, you got it all right. You got it all right. That's it.
Understand the power of storytelling.
That's it.
Talk less but say more. As much as I'm a technologist and I love for her to, at 16, actually she's taking coding classes, but I love when I read an essay that she reads that gives me goosebumps. To me, I'm like, that's the skill I want you to cultivate, because if you can write well, if you're comfortable speaking, and you're mindful and graceful in how you engage with others, there's a job for you, regardless of industry.
Yeah, you know, there's only one superpower in the future, and luckily we all have it, and that's the ability to teach yourself new things. That's it. And as long as you can just teach your, because, you know, when I'm 50 years old, I went to high school in the mid 80s, and if I went back to high school now and I know the future, there's only one thing I could have studied then that would be useful to me today, and that's typing. I wish I could. And the thing is I would have never known that. I would have never known that. And so it's like everything I have learned, I've taught myself, or, you know, other people, I have learned it as we go. And luckily, everybody can do that. If you do what Vala just said, and you learn how to communicate and be a good person and listen and tell stories and all of that, there's no, you are the most amazing thing in the entire universe, and no machine can do those things.
Absolutely. Absolutely.
Thank God for natural language processing. No, I was kidding.
Well, it can process it, but does it?
I'll tell you, Ray, somebody asked me for my home number the other day, and I'm like, I have no idea. And they're like, oh, how about your wife's cell number? I'm like, I just hit Stacy. All right. I don't. So it's funny how I've lost the ability to just know. Like,
you know, that's, by the way, that's a real thing. Did you know that in antiquity, 2,000 years ago, people's memories were vastly better than ours? We know of a Roman general that knew the names of all 20,000 of his troops and the names of all their family members. And we don't know this because it says he has a good memory. It was just, he has a nice guy. He's a nice guy. He remembered all these people's names. And even Plato said, he predicted this. Plato was no fan of writing. He said that with writing, you have only made a system not for remembering anything, only for reminding you of things. And he predicted that if literacy became widespread, if you could write down everything, you know, or look it up, your memory would go. And that's why, you know, I can't remember my PIN when I go to the bank. And that guy knew like 50,000 people's names. And it is true. Technology does change us. Did you know that, for instance, we know of the first time somebody ever read to themselves? It was about in a book. We hear about it. Up until this point in about the year 300, every time people read, they read out loud, because everything people knew, they heard. And so all the time, when writing came along, everybody just read it out loud to themselves. And the first time, you know, somebody read to themselves, it was regarded as really crazy. Like the words went through the eye onto the brain.
Unbelievable.
So technology changes us, but it increases our productivity.
Yes,
makes it better.
Yes, it does.
You know, related to stuff they were talking about earlier, and in your book, that point, you know, will machines ever get rights? Will we be like sitting there, and I know we talked about this at one point, like, you know, we have these statues of people being felled. Are they gonna be like machines felling down human statues? I mean, like, what point will machines have rights? And like, at what point do we have to make sure we think about those ethical considerations?
You know, I spend a lot of ink on that topic, because the short answer is, if machines can ever suffer, they have rights. We base, you know, the fact you can't torture animals on the fact that they feel pain. And yet you can take antibiotics and commit genocide against bacteria and nobody complains, because the bacteria don't feel pain. And so the question is, how would you ever know if a machine felt pain? Because two possible things could happen. Is it could experience pain and not be able to tell you. I mean, it may be this amorphous, or it could experience pain, claim that it experiences pain, and people not believe it. And to really drive it home.
Wait, that happens with humans already.
Yeah, exactly. Yeah, how many kids get out of going to school on test day because, yeah, Mom, I don't feel good. But the thing about it is, you share half your DNA, you know, with a banana, with a tree. And if I were to say, can that tree feel pain? You'd have to say, I don't know. I mean, I assume it doesn't, but how would you know? And the question is, if you can't tell if something that's like life is related to you, that tree is related to you, all life came, you know, for one time on this earth, how would you ever know if a machine experienced it? And the problem is, you don't want that to happen. I don't think you want machines to be conscious, because the minute a machine can experience anything, you can no longer You can't send the bomb thing in to disarm the bomb anymore because, you know, it's like, why do I have to go in, says the bomb robot. And you can't have it, you know, plunge your stopped up toilet. But you can't program it to do that. You can't even program it to want to do that. That's just brainwashing it at that point. And so life is much simpler if our devices stay like this. I don't believe, you know, the whole idea that a machine can achieve consciousness or even sentience, which only means sentience, people think means it's smart, but all it means is it can sense, it can feel. The only reason people entertain that notion is it's based on the belief that people are machines. And that animals are machines, and that life is fundamentally mechanistic. If you believe that, then yeah, it's inevitable. We'll build machines that are alive. If you don't believe people are machines and that life isn't necessarily mechanistic, it could be any number of other things, but that it's not fundamentally mechanistic, then machines and us are not anything in common.
That's just, wow. Sorry, my head is, there's going to be smoke coming out of my ears soon. Okay, so you interview some of the biggest brains in this space, AI, some of the top domain experts that have spent a lifetime working on artificial intelligence. So can you just tell us something about AI that we don't know?
Yeah, I mean,
at least for me, it would be easy. For Ray, you might have to stretch.
No, I mean, I've learned a bunch on that show. And the reason I did the show is I think we're at this moment, which both of you have alluded to in this episode. We're at this moment where the world's changing and we're all very contemplative about it. And the only corollary to this that I can get at is, that I can see, is the atomic era. The people that were working on the Manhattan Project, building the bomb, they too knew they were at the dawning of a new era. And there's all kinds of writing about, well, what does this mean? And what does it say about us? And how will we make sure this is used for good and not bad? And all of these other things. And we're so lucky that we live in a moment when this is all happening and that people have the presence of mind to see it and to reflect on it. And so I try to do something that sounds very boring, which is I ask my guests all the same questions because I think people will look back and say, wow, look at this. These really smart people in the middle of this world all thought different things about this. And so the first question I ask people is, what is intelligence? And nobody knows. Nobody knows. There's no consensus definition of intelligence. Then I say, why is artificial intelligence artificial? Is it artificial because we made it, or it's not really intelligence? It just pretends to be intelligence. It's just like artificial turf isn't really grass. It just mimics intelligence. And there's no consensus on that. And then I say, are people machines? And every one of my 100 guests, except 5, said, of course. What else would we be? What else would we be?
Really? 95 said.
Wow.
Yeah, and when I put that same question on, and when I wrote that in my book, my editor wrote in the marginalia, does anybody really think that? And I'm like, yeah, everybody in AI thinks that. And they're hostile to the debate that we're not. And
wow,
they usually invoke the word magic. You have to appeal to magic or you have to think we're machines. Then there are 5 people, I mean, I can name them, who don't. Esther Dyson said, no, machines don't have souls, you know. But you don't even have to believe in the soul to not take a mechanistic. We could be these quantum phenomena. You know, there are all kinds of things we could be that does not imply you can create it. Then I say, is a general intelligence possible? Can we build an AI that's creative and smart? And those same 95 people say, of course, always with the same logic, which is, look, if you took every atom in your brain and just modeled it, that would be you. Then I say, when will we get it? When will we get general intelligence? And the range that I have so far is 5 years is the soonest. 500 years is the furthest.
Wow.
Oren Etzioni said if it's within, he'd give anybody 1,000 to 1 odds we won't have it in 10 years. Check the transcript on that. But anyway, and you know, if you dropped your clothes off at the dry cleaner and they said they'll be ready in 5 to 500 days,
yeah. But Byron, if it was a Gaussian distribution,
25 years.
25 years.
But here's the thing. It's always been 25 years. If you look back across time in 1980, 25 years. If you looked in 1990, 25 years. It's because it's a very convenient time. Like, it's near enough that you should be worried about it, but not near enough that anybody's going to remember you ever guessed that.
Perfect for government funding of research.
Yeah, note to self.
Yes.
Next time somebody asks for my prediction, it'll be 25
Say,
years.
what's it going to do to jobs? And that's 50-50. Half the guests are like Kai Fu Lee in AI Superpowers. It's like, we're in bad trouble. And half the guests are like, that's crazy. That is crazy. And it's really interesting to see them on this clear divide. And then I say, what are you worried about? Because everybody, we all know what could go right. Cures and long lives and all these things. And then I say, what can go wrong? And then I start throwing bad things at them. And there's one that every single person says they're worried about. Tune in next week and I will discuss that. No, I'm kidding. So there is one,
So awesome.
there is one that everybody worries about, and that's privacy.
Privacy, yeah.
Well, the idea, and 30 seconds and I'll be quiet.
Please.
In the past, there's so many of us, you can't follow everybody and you can't listen to every phone conversation and you can't keep up with where everybody's going. But with AI, which can read lips now, and it can voice, like you said, speech recognition, every phone call, model every email, every GPS, everything. And the tools we're building to find cures for cancer are the same tools you'd build to model us and to shape our behavior. And that is one I have I'm an optimist. I wrote a book called Infinite Progress. And yet I don't have a good answer to that. The price of liberty is eternal vigilance. And if we want to have any kind of privacy left, that's the one I think to keep your eyes on.
There's one guest that we could spend an entire hour speaking with, and you're one. Thank you so much.
Thank you.
We are here with Byron Reese, CEO, publisher, and author at Gigaom. You can follow him on Twitter at BYRONREESE. Thank you again, man, for being on the show, and we'll catch up in Austin again soon. So.
Brilliant. Thank you so much. Please come back.
Bye-bye, guys.
Thank you, sir. Wow. He is so smart. I mean, I could listen to him all day. He's just masterful with how he explains his point of view in such a simple, orderly, and relatable manner. So yeah, he's brilliant.
Amazing stuff. And we've got more amazing stuff. 152 coming up next week. We got some
episode 152. We're inching our way rate to 400 unique guests. Just want to let you know. And when we hit that milestone, there'll be a DisrupTV digital party that we're going to invite all of you to. But next week, we have Dr. David Bray, Executive Director of the People-Centered Internet. This is an organization that's thinking about connectivity, ethics, improving society, and really leveraging technology for betterment of everyone. We have Keith,
I think Kirtika.
Subramanian, Senior Capital Markets Associate with Minslavan, and Najda El Fertasi. And Najda is the CEO, founder of Nadia El Fartsi, EQ, Emotional Intelligence Coaching, Consulting, from Brussels, Belgium. Is that where the home for Najda? And we have Kristen Laughlin, founder, CEO of Avion Consulting Group. So 4 really smart people. It's going to be a jam-packed show. I don't know if we're going to do it, panel style or one by one, but tune in next week to find out. Ray, closing remarks on a Friday where we know if it's Friday, it's DisrupTV.
No, I think we've got some great and more exciting guests coming up. A lot of exciting things happening on the Constellation front. In a few more weeks, you may find out who the BT150 winners are. And of course, for those who are putting in nominations for the Supernova Awards, you've got to do those pretty soon. You can see on the Constellation website under events, Supernova Awards. And these, of course, are the top transformation awards in the world, looking at folks that have actually done very cool transformation across our categories. So definitely check those out.
And you're giving a talk next week in Chicago. What's the talk about?
We're talking about vanity metrics and AI in marketing. So,
Hey, did I tell you how many followers I have?
exactly. What are you doing with those followers? So we can talk about vanity metrics at Salesforce Connections. I'll be there on Tuesday. So look for all you folks that are out there at the Connections event. And then, of course, I'll be at the IBM event. They have an event at Almaden. It's with their top 100 customers there. And of course, Monday and Wednesday, I'll be at both. They're dual head events that are going on. They break them up into 2 days. So
That's awesome.
Well,
I look forward
see you at Connections, Vala. So.
Yeah, I look forward to seeing you there. Thanks, everyone. Please recommend guests for the show. What we want to do is get you closer to people that you admire and people you want to learn from. And by doing that, we learn from you. So please let us know. Follow us on DisrupTV show. Send Ray, myself, our amazing producer, Aubrey Hoggins, your recommendations. And we've got the next half of the year to book guests that you want to hear from. So help us get to that 400 unique guest milestone. And thanks for watching. See you next week. Bye, everyone.